Welcome back. This is session 4, the last part. In this part, I would like to emphasize on the life cycle of data science project. Let's take a look at the slides. If you take a look at this data science life cycle, although this is specific to data mining, it is as easy as replacing it with any other application in mind, and still it's going to work. This is knowledge discovery in database, knowledge K, discovery D, database D, and that stands KDD. That's how the KDD came to life. If you take a look at this pipeline, the first part is data. Are you collecting it from hardware? Imagine you have gone to a doctor and the doctor has connected your body with heart signal sensors on your arms, on your chest, perhaps on your leg. Is one of the sensors loose? The oil or liquid used to attach the sensor to your body, was that conductive enough? Or was it not conductive, and therefore the signal that is coming from the heart signal that is coming from those sensors may not be as reliable? This is happening across the board. If it is hardware-based, then you have a bit of information and a lot of challenges in mind. A bit of information because you know where the hardware has been deployed. You could potentially even take a look at the correlations of the sensors together. At the same time, the challenge is the data that is coming in could potentially be malfunctioning. Anomalies are going to be quite basically visible. You do have overlays and so on. The data is coming, but the problem is you need to clean it. So as soon as you get the data, you need to do what we call processing the data. And processing the data is indeed pre-processing before the algorithm kicks in. Pre-processing and then post-processing. So this pipeline is going to manifest itself in many forms, some of which I'm going to explain on this presentation, and some of them are going to explain in the next session, in the next session number 5. Now, so basically, when you take a look at the data, there are missing information. How do you intend to fill in the missing information anyway? And there are techniques for that. If there is a noise, how do you plan to denoise it? If there's something odd, how do you plan to basically identify it and grab it with the needle and basically a scissor and cut it from your data? You need to have the data ready in a good shape so that your program, that is a machine language, can understand it. The program does not understand the type of information per cell or per column you're going to feed it. It's your responsibility to make sure that the data is clean and the data is consistent and the data can be utilized. And as you can see, the data as incoming, as well as the pre-processing, if you remember from a few slides back there, in the previous part, you would remember that almost 60% of the job of a data scientist is about the data collection and cleaning. And it's not necessarily an easy job. It depends on the nature of the application. The data cleaning process is going to be different, and pre-processing is going to be different. Now, sometimes the data is big. It's really large. For example, you have a camera with 20 megapixel. You have a camera with 10 megapixel. You have a lot of information, and it comes to you, and the question is, are you going to actually process the entire 20 megapixel, or are you do you intend to process only a portion of it, a small portion of it? It's very important. And if you want to do that, of course, you need to do what we call dimension reduction. You need to reduce the dimension, 20 megapixels. Maybe you can do what we call compressing. You compress the data and you present it with the fewer dimensions, with the fewer rows and columns. Sometimes the data that is coming at you is going to be sparse. I mean, let's be honest. Yesterday, how many sentences have you spoken of? Okay, you have spoken. How many seconds in your life did you have? Let's start with seconds. If you consider a minute is 60 seconds, if you consider an hour is 12 hours, if you consider a day is 24 hours, you had huge number of seconds that you could have. How many of those seconds have you been talking? Much of that time you were silent. That's called zero. When you were talking, how much useful information you were talking about? Okay, let's be honest. Yesterday, do you remember any significant sentence you have been speaking of today while you're listening to this presentation? Do you remember any useful sentence at all? The reason is much of what you have heard yesterday were kind of repetitive, kind of irrelevant, kind of useless. Your brain automatically is actually filtering all of that. And that's how the data is ready. So the data is ready through a number of stages, and then you can replace data mining with any other algorithm. And the other idea is, can you identify the patterns? Can you see the patterns in an image? Can you see eyebrows, nose, ears, forehead, chins, cheeks? So those are the things that you are going to look into, right? Image processing. If you take a look at the voice, can you identify from many voices you have heard yesterday, which voice was your mother's voice, your father's voice, an important voice, maybe your teacher's voice? So you are actually trying to extract basically information. And those are some of the algorithms we are talking about, and potentially we touch briefly in a very basic form some of these points in future. Then you need to actually do what we call, in terms of pattern, you need to do clustering, classification, regression. We are going to have some slides on that. In terms of the knowledge discovery, what you need to do, you need to basically do data visualization, and then you are going to do result interpretation. The matter of honesty is that the data is so big, and even after transformations, after basically filtering, reducing the dimension and everything else, still you cannot understand what the data means. They are all zeros and ones, perhaps a decimal from 0 to 9. Hexa, even worse. The numbers are at your face, and you don't seem to understand what they are. You need to present them visually, because humans understand the data in a visual way a lot better. And there are techniques for visualization we will be talking about. So how is the course structure in general? We have spoken of, we will be talking about the data in a moment. We have spoken of experiment and how to conduct the experiment in session number 3. You already know, for example, tossing a coin, a dice, whatever it may be. You already know where the data is coming in from a game you play, from a puzzle you're trying to piece together, right? So basically what is happening in the next few slides, especially not next few slides, the next lecture, we are going to talk about where the data is coming from. Then we are going to talk about how to clean the data. Then we are going to talk about dimension reduction. Then we are going to talk about the algorithm, which is going to be a heavy portion of the class as well. And then we are going to talk about data visualization. I need you to remember this pipeline. This pipeline we stressed in session number 3. We are stressing in session number 4. We are going to stress that many, many times. There are different types of life cycles, data science process life cycle, which is TDASP. Basically, you do have a business. This is related to business environment where you are going to understand the business. Is it an e-commerce? Is it a finance? Is it a transportation? Is it going to be medical? Whatever it is, you are going to understand that. And as you can take a look, you're going to do a data acquisition. Data acquisition means acquiring the data, inquiring the data. The data has to come in, and then you need to understand what the data is. You need to model the patterns or model the data. Data modeling is going to be here. You're going to potentially go through this cycle a number of times. You could potentially even deploy it in a pilot project, not in a larger scale. You don't want to even send it back to the customer yet. You want to make sure that as you deploy, it's going to actually make sense, and you are going to fix all the bugs. The coding bugs, whatever it is, hardware bugs, software bugs. And then what happens, you're going to go through this a number of times, maybe back and forth between the modules. And then when you are confident that your project is actually completed successfully internally with all the stress tests that you have conducted, you're going to send it to the customer, and hopefully the customer is going to give you great feedback. And the customer is going to give you useful feedback. Maybe you want to go for beta 0, beta 1, beta 2, beta 3, alpha 1, alpha 2, whatever you call it. And then whenever the customer is going to be happy, the latest version of the basically algorithm is going to be deployed wherever the customer wants it to be deployed. Now, we talked about data acquisition. In data acquisition, we are talking about data source. We have the streaming versus batch. Streaming means real time. Batch means it's already passive, behind the scene, running. Depends on the frequency of the data that is coming in. This is data pipeline, not the data science pipeline. This is data pipeline. The environment, what is the environment the data is coming from? We talk about wrangling in next lecture. And then in terms of modeling, we could potentially be looking at feature extractions, feature engineering, model training, and model evaluation. Obviously, this has to be done a number of times. Keep in mind that I may have to do modeling, and after all the modeling, I may realize that I have one attribute missing, and I have to go back and see where my data source is telling me. Maybe that was there. I simply wanted to simplify. I ignored that column, and that's why I'm going to pay a price. And the price is going to be delayed project. So keep in mind, this is a comprehensive pipeline, data science pipeline, okay? This is the last one, I would say. In this case, data to insight to decision, how whole of life analytics. Take a look at this. I have a couple of columns. This column, that's a past. This column, that's a present. This column, that's a future. This column is going to be decision, okay? So let's take a look at the past. In terms of data, I'm taking a look at the historical data. I'm going to perform historical analysis. For example, stocks. I'm going to see what happened in the past. And I can see that there has been some stock crashes and stock rising and stock falling for a particular stock ticker, for example. How and why did it happen? I'm going to try my best to actually model, and all of these are going to be applied onto the data from the past. Once again, this is another form of the pipeline. I need you to seriously remember the pipeline, and because we are going to try to talk about each segment of the pipeline as we go to the next course, next lecture. What is happening? So I'm going to detect, I'm going to alert. This is going to be as a real-time data that is coming in, the present, the data is coming in. What are the key driving factors? At this time, I'm in the present time, I need to intervene, something might be wrong. Maybe the risk to reward ratio is not within the margin or threshold that I want. So I have to have some risk management. If you want to go and trade in a stock, one of the things you need to do, well, in the past, you were able to understand what has happened. And that's majority of the paper publication come for a stock analysis. That's the past. But then at the time, when you want to execute the order in the market, you need to do execution management. You need to do risk management at the very time you are going to execute the order in a stock. So that's really important, right? And then you get to the future. What will happen? Can I think of what is going to happen tomorrow in that as a particular stock X? How and why it will, when it will happen? Basically, I'm going to predict, I'm going to position myself for tomorrow morning at 9:15 a.m. I'm going to start selling or I'm going to start buying depending on the evidences in front of me. And that's going to be the future. Now, decision, What best action to take? So as soon as I have done all of the past analysis, I have done many trading on a real-time basis. Doesn't have to be day trading. You could be swing trading and still you are going to be considered real-time. And then after I have been able to adjust my algorithm, fine-tune my algorithm, now I have a prescription. I have a prescription and I can apply that prescription guideline, policies, rule book. I have prescription that I can actually apply for upcoming week or months or year. What's the next best action? Optimization or recommendations. So obviously this is not going to be the best of the decisions unless you know that the decision you have taken is the best. And the way you are going to do it, you are going to go through optimization routine and optimization algorithm, where you are going to actually modify algorithm and take a look at what we call sensitivity analysis. Sensitivity analysis is going to tell you a little bit, not only about the past, but also it's going to help you optimize for the future. So if you take a look at this, this is in line where we discussed, you are going to consider this pipeline all the time. It's going to be selection, pre-processing, transformation, data mining, or any other algorithm, and then interpretation, evaluation, and decision. I think we have assessed that long enough, and I hope you pay attention to that. And as soon as we go to the next sessions, you are going to map, you're going to keep this in your mind so that you can see where we stand, segment to segment of the data science lifecycle. Thank you very much.